Thank you very much to the host of ICONTENTION 2022 and also the participant. So today I'm very honored to be invited to share with you some topics related to AI. So first of all, let me share my screen. Please hold on with me for a while. Can you see my share screen? Okay, good. I can see it in the screen. So I think without further ado, we shall start with our session today. When I was invited, I was so hope you will enjoy with my sharing. So first of all, I would like to introduce my university. I'm from UTeM, Universiti Teknikal Malaysia, Melaka. If it's not familiar, maybe to you, or you may be first heard of this university. We are one of the technical universities in Malaysia. There are in total 4 technical universities, which are focusing on engineering and technology courses. So we are, UTeM is one of the 4 UTeM tone university. So we are located in Melaka. So if you can look at the map, it's not far from Indonesia, and it's not far from our capital, KL, as well. So we have 2 campuses, our main campus and our technology campus. We started our journey in 2000. Now we are already 22 years. Okay, a very quick intro to my faculty. I'm in the Faculty of Information and Communication Technologies. We are offering courses from diploma until PhD, Doctor of IT from 3 different various levels. So we have full-time, we have part-time, we have online courses as well. So basically, we have 5 departments, and I'm in the ICA, Department of Intelligent Computing and Analytics. So in this department, we are mainly offering AI program, data science program in master and research track of master and PhD. So a little bit about myself. This is my research landscape. From what you heard from moderator, you know that I started my journey from data mining. Then I slowly moved to machine learning, then also AI. So machine learning modeling is my research area, and I'm focusing on adaptive model like uncertainty analysis, when it involves incremental, where you want to every time update your model from time to time, not just one time train, then use it forever. You need it to update the knowledge inside. You need it to update from time to time. I'm involving in those kind of research. I'm also having research in association rules mining. This one is basically used a lot in data science for root cause analysis as well. And also I'm in doing studies in model interpretation and evaluation, how to manage machine learning experimentation, and also today's topic, explainable AI, is in model interpretation. So these are my fundamentals. So I use this fundamental model and techniques in some focus area like machine data, basically for manufacturing, retail analytics for online retail, then learning analytics for education and user profiling for our youth and sports ministry. Then I'm also very interested in biological data like brainwave, muscle signal, and also the lung nodules abnormality prediction. These are involved in biological data analysis. I do have some work in route management. This one, I use this, I'm in this area to basically join the competition. We join some competition with my students in the national levels. So this is basically a brief intro on my research landscape. Okay, so now I would like to share with you what is explainable AI. Maybe some of you have heard of it. Maybe this is the first time you listen to this kind of topics. So I hope I will bring you from basic, why we have XAI, until what are the possible application, and also at the end future research direction if you want to venture in this area. So we will start from what is it, and from where it comes from, why is it important to consumer and user, the definition, the solution, good and bad, the way forward, and last but not least, the conclusion. Okay. So when we talk about AI, we know that AI started in very, very early age. I think many of you are in maybe in this area or maybe use it before. But at this era, it started to bloom very quickly and emerge as an important enabler in many domains, many applications across various platforms. So because of the technology of internet, technology of data analysis, and also the AI itself, so that's why now you can see a lot of application in many use cases. So when we look at the evolution of AI started from handcraft knowledge, where this is the first wave of AI many years ago. And this handcraft knowledge basically to provide description, like it try to generate knowledge from human experts, then put it into a system and let it run and do some intelligent job. So second wave started to use statistical learning, and after that changed to machine learning as well. In coming into the picture, we try to provide categorization like classification, if you heard of classification, clustering, and this kind of tasks to improve the application of AI, to make it more predictable. From you are able to do diagnosis, you are able to do prediction until prescription. So that is the second wave of AI. Now we are in the third wave of AI, where we are more concerning about contextual reasoning. Contextual reasoning means other than we provide prediction, we provide recommendation, we want to explain as well why this prediction or this recommendation are as such. So why the AI model give you this explanation? What does it mean? What is the contextual meaning behind? So human try to understand this in the third wave of AI. Okay, so when you look at the XAI, it actually started in 2018. It's quite a new one. It started to become a popular topic when DARPA from US make it inside one of the initiative under AI Next campaign. This AI Next campaign, you can search for this information in DARPA website. AI Next campaign is to gather researchers to do some research which is for the future. So XAI is one of it. So when we talk about why we want explainable AI, is because when we use AI in many applications, practitioners found that when AI, especially those complex model, the complex model giving explanation, giving prediction, human user kind of do not understand why this prediction model come up with such prediction. They don't understand. They can just, if you want to follow, you just follow. If not, they won't use it. So this kind of situation create a discussion, debate in those mission critical application or life-threatening application. For example, like military application, medical, a lot of medical. So you can see that in medical, AI is still using as an assistant, but it's not a decision maker. It only helps doctor to make decision. It's only like a tool to give you more additional info, but it cannot stand as an evidence for law. If you want to go to court or you want to take regulation, you cannot use AI evidence as it, because the main reason is at that time we cannot explain why AI gives such application. So these XAI topics actually coming from the practitioner's view. So when people, AI technology is ready, go into use, a lot of businesses are start to realize the benefit of AI, the capability of AI, they want to use it. Then practitioners kind of discussing and debating. If we cannot understand what AI is doing, then how can we use it as an evidence to make decision, especially those in the life-threatening use cases, mostly in medical and law enforcement, and also military application. So that's why this AI become a topic in AI Next and become very popular. Until now, a lot of later we will see the graph given by Gartners. You can see the trend. Okay, so when we look at the hype cycle given by Gartner for emerging technology in 2018, there is no idea of XAI yet because AI Next campaign is towards the end of the year. So when we look at 2019, you can see that XAI is coming into the picture, and it is still inside the innovation trigger, means a very new concept that people start discussing and doing research. So, but when you look at the trend, XAI is now go after the peak of inflated expectation, means people start to use it, test it out in many use cases, many real application just within 1 year. So you can see the importance of it. So it is not coming from the research requirement or needs, but it's actually coming from the practice. When practitioner wants to use it, they need to look at this perspective. That's why I think that this is good to discuss in today's conference. So after 2020, if you go and search in the internet, Gartners had dropped XAI from emerging technology in 2021. But it doesn't mean that XAI is not important. It is not an emerging technology already. It is a common technology that everyone should take into consideration. So when you look at the HIP cycle, XAI is now under responsible AI because it is under one of the topic under this umbrella in AI HIP cycle 2021, and you can see it climbing the slope very fast in AI HIP cycle of this year 2022. Okay, so now this trend and this analysis from Gartner tell us that XAI is actually an important topic. That's why it evolved very fast, and until today it should be considered in many technology application innovation that engineer develop, computer scientists develop, or data scientists or practitioners are using. So you must consider this now. So without using it, probably that is a gap inside your R&D. So I hope that this will be a call for us, including me, to be considering explanation of AI model in the future of our R&D application development and so on. So now, after we know the motivation, so probably we can come back to look at where and how we should explain the prediction of machine learning models. So when you look at machine learning model, we can see they are we need data because we are using a data-driven way, and we need algorithm, some techniques to use. Techniques are like, for example, decision tree, the most basic tree-based, logistic regression, KNN, neural network, fuzzy model, and many more. So we are using the algorithm to create our model. Using algorithm, map on the data to create our model so that our model can be used as an output to do some tasks, intelligent tasks, including descriptive tasks, diagnostic tasks, predictive, and lastly, prescriptive tasks. Okay, so this is a basic view on machine learning model. So where is XAI? So when we have this learning model, XAI is a part of it or additional part. We can use two approaches where it can be embedded inside the model, or it can be one additional module. Later we can see in the slide. I prepared the slide for you. So now we try to look further how to where can we use and where it will sit. So just now we say we have a model, explainable model. So this is an example of image recognition and using the neural network learning function. So if you look at this is a network learning function. So today's when we are using a neural network learning function, be it a perceptron, multi-layer, or deep learning models. So we are feeding the data into the function. We hope that this technique will learn from the training data and provide this output when we feed them with testing data to predict. So let's say we feed them in with a cat image, then it will predict, say this is a cat with some belief of 93% probability. So today we can get the prediction, but user might want to know, why do you say this is a cat? Why is not something else which is similar to the cat, like a squirrel? What is not a squirrel? What is a cat? So when do you succeed? When do you fail your model, learning model? When do you fail? Can I trust this model? How do I correct if that is an error prediction? So users are curious in this kind of question when you put your model into application, okay, in the real use. So the current learning process cannot achieve that. So we need something to explain what this intelligent model is given out as the output. So tomorrow, that means now we are looking at XAI, which we have explainable model and explanation interface. So this explainable model include the original machine learning model and also the explainable AI, XAI model itself. It can be in one hybrid, like under one model hybrid inside, or it can be two separate additional one. So when we go to application, when we develop the application, since we are having this explanation capability, so we will have one explanation interface rather than just output prediction interface. So this explanation interface will further explain to the user why this is a cat. Why is this AI model saying this is a cat? So it say, oh, it has fur, whiskers, and claw. It has the features such as this, the ears. Okay, so these are the further explanation that provided by is on the prediction of the learning model itself. Okay, so this kind of process and approaches will be able to fulfill the human user or consumer requirement of understanding why this AI model tell me this. Why it say this picture is a cat, it's not a squirrel, and so on. Okay. So I will also know if, let's say, the explanation and the picture are not the same, so probably the explanation is not the correct one. So I know when this model will fail, when it is higher, when it is actually with a higher trust in prediction. Okay, so that is the motivation and what you can imagine when you have XAI in your development application. When we are looking at application development perspective. So why is XAI important to consumer? If you are putting XAI in a consideration factor to develop your application, to develop your AI technology, what do you promise to your user or consumer? So we can look at 4 different perspectives: explanation, performance, meaning, and control. So we look at it from the domain knowledge. That means the engineering of knowledge how we acquire the knowledge inside the learning model. So how do you gather that the machine learning model gather that? So with XAI, you can ensure efficacy because you know not only the prediction, but you know why the model behaves as such. For that, you also can make sure your performance is improved because you won't prone to making mistake. If your belief or your probability of trust of that prediction is lower, through the explanation, we will understand that as well. Then the meaning, you can discover the meaning of the knowledge, not just blind black box mapping and relationship mapping. You can understand why the deep learning model behaves as such, what kind of knowledge that it can find from the data itself. So at the end, with all this capability, we can improve our model during the maintenance process. We can make our model better and better because we know what is the weakness. That's why we can make it better. From the application point of view, so when you have this learning model, you want to put it into a real use inside application. What is a good thing about having this XAI interface? So first, we can let the user know what to expect a lesser confident prediction or high confidence prediction in the future through the prediction every time you use the application. You can identify strength and weakness, and you can know why this intelligent application predict. What is the rationale behind when intelligent application predict go into a higher level of AI use in real world, where we are talking about human-machine cooperation. So this is one of another set of the goal, even in my research, is going towards that human-machine collaboration, human-machine cooperation. Because we human understand what the AI behave, how they behave, why they predict as such, we can work with them. We want to work with the machine, you have to understand it first. Okay, so that is to promote future collaboration between human workforce and the machine workforce, especially when the industry put in a lot of automation effort into their. You want to look at is the governance. We know we have good AI, we know they can do a lot of things, we know why they are behaving as such. We also want to be able to govern the AI model itself, the AI intelligence application itself. Govern means we want to control, we want to know, we want them to do good every time. We want to manage the risk. So from the governance point of view, XAI can promote better justification to regulation and policy. So this is one of the main focus why XAI come into the AI research landscape, because earlier on we say when we are doing deep learning model prediction, for example, we cannot explanation why the prediction come out as such. So we cannot make them as evidence for laws and medicals and probably the regulations. We cannot justify that. So with XAI, we can have better justification to the regulation and policy. Next, we can prevent bias. We know when this model not doing an objective prediction, maybe bias or something. We know that because it explains its prediction. So we can build trust through that. We can build trust in our consumer, and we can manage the risk of the AI application. So these are the importance that why we have to introduce XAI into our R&D output. Who will be benefit from XAI research? So first, definitely the domain experts. The domain expert. Many times when we say AI, especially deep learning model, we can see that a lot of deep learning model actually outperform the human experts. So that means it has found some underlying knowledge where this human expert haven't acquired yet through the use of the data. So human expert is the number one group that will benefit from this, because they can also learn from what the machine is learning. That will also go towards our goal of human-machine collaboration. Both of the human and machine will upgrade from time to time. Okay, so domain experts are like medical doctor, insurance agent, and so on and so forth, from the domain where we want to apply AI model to. The second one is the creator, the model creator itself. Model creator including data scientist, developer, product owner, machine learning engineer, and so on and so forth. So this kind of people, they want to have a better model. So when we look at better model, not only in the accuracy of the prediction, we also want it to have better acceptance to the user. Really can help the user. So we come up with this idea. We can see that this XAI is really helping in this point of view. So next is the user. Who else other than user is the major benefit from these XAIs? When user use application, intelligent application, they want some understanding instead of just output. So that is the better way for them to understand their situation and verify whether this AI recommendation is a fair decision or not fair, is fair or biased. Okay, so that is user. Then we have our management team. When we want to talk about compliance, when you create products, you will come to this compliance assurance testing and the regulation. So you will know that we have to have something to when we want to assess regulation compliance. If you cannot explain why it is like that, we cannot say it is compliance to some requirement. So the last one will be the regulatory entities or agency like law enforcement, police, medical staff, probably auditor. So these are the people when they are in the position of want to verify, want to model compliant, want to do certification into the model itself, the usage of it. So they need something to be clear and transparent. It's not black box. So when we talk about high-end machine learning model, high-end AI application, they are a lot of times come from complex model, because we need it to predict the complex situation. When you come from complex model, definitely the interpretation or explainability of the model is low most of the time. So how to make the model transparent? So that one is an important point from the regulatory entities. So next, explainability definition on XAI. So when we talk about XAI, explainable AI, so the focus is in explainability, how to explain the AI model. So when we look at explainability at this moment, we can split them into two categories. One is to look at the interpretability, and another one is to look at the fidelity. Interpretability is based on the existing learning model itself, how transparent, how simple it is to be understood by human user. And then fidelity is talking about we need another additional explanatory module to add on to our learning model. As just how I mentioned, we can have all-in-one, the embedded, or we can have one additional add-on. So there are two approaches here to implement XAI in your application. So look at it one by one. What is interpretability? Interpretability is looking at the clarity and parsimony of the explanation of the model itself to make explanation. If the model is clear and compact but not complex, so without the additional explainability interface, you can understand the model already. So those kind of model is easy to go into embedded one. So we look it as one. Okay. This interpretability is usually happen in those machine learning model which is by design easy to understand. Later we'll come to a slide on that. Second type is on the model which are complex. It's not easy to understand when you look at the model itself. For example, deep learning model, okay, is one of the obvious example. Look at the deep learning model, you don't understand what is behind the model because it's a black box. So for this kind of model, when we want to implement XAI on it, we need post hoc explainability. We add another explanatory module on top of the learning model to explain the deep learning model itself. So we are looking, when we are adding one more, that means we are looking on the completeness, how complete this XAI module can explain this deep learning model, and how sound, what is the soundness, how correct it describes the prediction from deep learning model. So these are the two different approaches where we can implement, follow when we want to use XAI in our application. So when we look at the interpretability and fidelity, it is always in opposite. If your model, machine learning model is easy to understand, then interpretability is automatically higher, and fidelity is lower, and we do not need to use it. In deep learning model, where the model itself, learning model itself is difficult, complex, so we need higher fidelity because the interpretability is not there. So it's always like an opposite measurement. Okay. So when you look at the models itself, for those who have gone through this kind of AI model, maybe you are familiar already with rule-based, linear regression, logistic regression, decision tree, k-nearest neighbor, generalized additive models, Bayesian, support vector machine models. So these are the common one in the that you can find in the research community, and also the application work. And when we look at this kind of models, some of them are simple. Simple means simple doesn't mean that not good. Simple means their model by design is easily understandable, so with high interpretability. For example, rule-based. A rule-based model is like you form it in a if-then rule. If the temperature is greater than 50, and then the efficiency is lesser than 30%. So this is very straightforward. When you give this kind of rule base to the human user, most of the human user can interpret, can understand why is it. So I predict today will I predict the machine will down because the temperature is more than 50 degrees, then efficiency is less than 30%. So it's straightforward. Other than that, linear function-based model, geometric-based model, similarity-based model, they are easily understood by human user. Okay, so with this kind of model, we do not need additional module of XAI. We can just highlight, get the visualizer model's outcome itself, just view it, then you can let your user easily understand why the model is predicted as such. So let's look at the geometric models. So the outcome of geometric model, the tree-based family especially, they are actually doing categorization, partitioning the search space into different categories, different category or different partition. Okay, so from here, user can understand why we say this result is maybe yes, or why it predict as yes, why it predict as no, because it's within this kind of variable value. So that's why the prediction is as such. So it's easily understandable. Okay. Another one, linear function-based. Function-based model, we have linear function and polynomial function. Even a more complex one like support vector machine. A support vector machine also we have linear and non-linear. So those linear-based model are similar like linear regression, easier to read the outcome. Example, those that are above the line, what is that? When those that are above the line, maybe we say higher travel time means busy time, non-busy time. So we can easily understand from the outcome of the model why the prediction is predicted as such. Okay, but when we come to non-linear model like polynomial or the SVM, then it will add up to the complexity of the model, and at that time the interpretability will get lower, and probably if let's say the interpretability is too low, we probably need to add one more module, explanatory module, so that we can, the XAI interface can easily explain to user. SVM model, for example, when we add on kernel, when you go into the kernel analysis, those are the things that will add on to complexity. So if your SVM model is just using a simple linear separation line, so that one is still easily interpretable. But if your SVM model is using the non-linear, higher order of, then those are complex model where we need additional explanatory module. Another one, similarity based. Similarity based are like K nearest neighbor. This is the simplest or most of similarity based. So K nearest neighbor, we are looking at grouping. So when you are looking at grouping, you know why I predict rate as rate, because they are grouping together with other data which are having the same characteristic. That's why we predict you as such. Why we are predicting a group of people with high income, low moderate education? Because they are similar to the same type of community. That's why we predict as such. So in this kind, explain, it is still high interpretability. But same thing, as we increase the dimension of K nearest neighbor, it will become more complex. So three dimension, you can imagine 3D. 4 dimension, people cannot imagine, maybe can imagine but cannot visualize anymore. 5 degree, 6, 7, 10, 1000 dimension is very hard to imagine. So that will increase the complexity of the model, where XAI is now coming into the picture, become more important than just the learning model itself. So those low interpretability models, which I say is complex, those are complex models. For example, higher order of ensemble model, deep learning model, those are models which we cannot, by looking at the outcome of the model, learning model itself, we cannot understand what it is, why the prediction is as such. So that is the motivation where we need additional explanation module. Okay. So I give you a picture on deep learning model. Deep learning model is neural network, also same, multi-layer neural network is actually coming from multiple function-based model, combine multiple function-based. One function-based probably easy to understand, but when you combine multiple function across different hidden layer, then it will become very complex. Another type, ensemble. Ensemble is popular now because by stacking and joining different models, we found that they are useful. And individually, they are not difficult to explain, but when you stack them together, put them together, then this become a complex model. You do not know how you get that prediction, because you try to stack up, merge them together instead of one single simple model. Like simple logistic regression, we can stochastic gradient maybe is a little bit difficult, but if you are using SVM linear model, we can explain. Multi-layer persistence is difficult. If you are using less layer, less neuron, then probably it's easier to explain. But once you stack them up together, you become very, very complex. Okay, but somehow this complex model, we found that they are good in performance. We want to use it, but across this obstacle of from the practitioner requirement, they need explainability. There is the reason XAI is coming into the picture. So what are the post-hoc explainability that we can use for this complex model? What kind of explainability, or how can you imagine the additional explanatory module when we come to complex model? So for example, when you have your learning model outcome, you can add on one more layer, include the text explanation to generate semantic mapping towards the task model and the text. For example, you want to do text handwriting recognition, summarization from text. Instead of you straight away output the prediction, you have some explanation that map the model and the text itself. So that is one approach of additional post-hoc. Another type, visual explanation. So we provide visualization to visualize individual behavior in the model itself, model prediction. So those kind of methods we have. What if tool, GradCam that I will show you later on. Next, we can have local explanation. Segmentize the complex solution into few we call it multiple subspace. From complex one with simpler model, then we explain it through local explanation. So we have this global local kind of structure. Next, feature relevant explanation. Feature relevant explanation are to explain the model outcome according to the data features, or we call it a data characteristic, data attribute. So we explain the outcome, relate the outcome to the original attribute itself. So and explain the performance of the model prediction. So this is one of the possibility. The example XAI under this category are sharp. In long name, it's called Sharply. I'm currently using this method in my brainwave analysis for computer task authentication. So I'm combining the global local and this feature relevance explanation using Sharp modified. This is one of the usage. And also next, we can also explain by simplify the model itself. We produce another model. You have a deep learning model to predict your task, whether cancer, non-cancer, and you add on with model to predict the deep models. That is explanation by simplification using another new simplified model. And the last one is explanation by example. You extract the data, see how this subset of data perform when you are using the model, and try to get the explanation from that. Okay, so now I will show you what is what if tools we are talking about just now in the previous slide. So you can find this, a lot of XAI library are there already for you to use. You don't really even need to create if your R&D research work is just to use it to explain your own model. You can just use the library, and there are many in Python. The basic Sharply that I use is from Python. So if you are not doing a modification on the XAI, so like myself, if I need to modify the techniques for some purpose, domain specific purpose, then I need to modify the library. So if I just want to use it, there are a lot available in GitHub. a lot available in many analysis platform like Azure. I also found it in Azure. So, and also other platform, I believe, which I never tried out. So you can try to find XAI capability or explainability libraries in your own platform if you are using other, like I know Google also have it. Amazon, if you're using Amazon and so as Amazon IBM platform, SAP platform, probably you can try search for it. I know there is an effort, good efforts in Azure, Microsoft, and also Microsoft, Google, and IBM on this. There are small other effort, and there are other platform also having this initiative. So you can always find if you just want to use it. For example, this what if tools is to explain the prediction. And if you this iris flower, this is the basic data set that every beginner of machine learning candidate will go through to predict the type of flower of this iris species, Setosa, versicolor, or virginica. So this what if tool is actually trying to tell whether the prediction, if I predict this flower as a Setosa, why I predict it? Is it because the features, the first features is showing a concentration trend towards this breed, this species, or some other reason? Okay. So other type of XAI are in the long name is gradient weighted class activation mapping. So it's trying to use the gradient of the targeted concept. For example, this dog. So when we predict this image, we want to predict which is dog, which is cat, right? So you fit it into the deep learning model. You want to know which is dog, which is cat. So when you have many input images, then you let this deep learning model try to learn. The model will try to differentiate what are the part that having higher gradient that when we predict it as dog. Which part are having higher gradient when we predict it as cat. So and module will give you the visualization as such. For dog, you see the red color, yellow, green towards blue. So the red color are the reason why the model predict this as dog. And also for cat, why the model predict this part of the image as cat, because of the features here. Okay, so this is how it explains. Another one, line. Line is also a very popular earlier models of XAI. It is more on interpretability. So it is different from GradCam. GradCam is more on explainability. Line is it is originated from interpretability. So it interpret also cats and dog. So it tries to tell you from the model itself which part of the feature will point towards dog, which part points to a cat. So this is an image. This is another example when we have tabular data, image and tabular data. So tabular data, when you predict, other than the prediction, whether it's edible or poisonous, this is a mushroom example, also a common benchmark data set. So which mushroom is editable, which mushroom is poisonous, other than giving the probability and the output, prediction output, XAI also looking at this features explanation. The model will predict it as poisonous because the odor equals to 4 is with higher value, the stalk surface, the spores, the stalk surface, and so on. These are on the positive side. And when you predict as edible, you can see a surge, a high surge in gill size. In this gill size equals to broad. So when gill size is equal to broad, you say, this is edible. When gill size is equal to a smaller one, not so broad, maybe round, and no, maybe not broad, is a very small, that is not edible. So these are the things that the XAI line module will try to tell why the output is as such. So when you run the program, the run program. If I'm using Python, you launch this lines library, you run the program. Other than you run the prediction, you just run the library to generate the line visualization or line output. Then it will give you this kind of prediction. Then and we will need to think how to represent this XI outcome in a better way in our application. That is towards more storytelling is in your dashboard or in your application. It's another different story. Okay, but at least it generates this that we can tell our user why it is poisonous. Sharply is the one that currently I'm doing a lot in my biological data. So this is also a differentiate which is the part that when we are having a positive sharp value or negative sharp value, a high. Maybe when you see the color, when this bird, you see whether it is a dove-witcher or a red-backed sandpiper. So we predict this bird as a dove-witcher because it has a higher value of sharp in a certain part of the picture. For example, the beak, okay, and the body feather. So those are the features that why this deep learning model will tell you that this is a dove-witcher, this is not a red-backed sandpiper, and so on and so forth. We can also have example for like this sharp value. If you want to recognize apple and strawberry, when you predict it as strawberry, you can see that the features concentrating at this place that shows that this one we predict as strawberry is because the shape and surface like this. This is not a Granny Smith because we see the sharp value is very light. I mean, not dark. Not dark means nearer to zero. Nearer to zero means not so significant. So it is not Granny Smith. It is not definitely a fake. Okay, so that is how sharply explained. RISE has been used in many deep learning model as well. It is basically based on the concept of randomly mask other part. Let's say you want to predict sheep, you mask the picture randomly, try and error mask every part of the picture, then you see which one you show, and then you visualize it in a different shapes. So you see the pictures, first row, second the picture at the middle. This is the importance map of sheep prediction. We predict sheep because of these features. Actually, in the original picture, both are sheep. One is white, one is brown. But you see this model, it can only recognize the white sheep. It cannot recognize the brown sheep. It sees the brown sheep as cow. Wrong prediction, right? When we look at this explanation, this important, we know that this prediction model is biased to white sheep. It doesn't want the brown sheep. A real story by a researcher. When this researcher found that AI algorithm, which we do not understand, which is a black box, is actually having bias. They found that this AI algorithm is having bias towards the white compared to the black. And in the community, the skin tone, black and white compared to the black. So this is some of the, you can look at this example, like why it happens as such. Okay, it focuses on only the white type, but in actual both of these two animals are sheep. They are just different color of sheep. Okay, so when we have this explanation, we know that where went wrong. So we know our model is having bias. So how to manage risk? We know that there's a risk in making error in those data where we have black sheep or brown sheep. So that is a risk that we need to monitor, and we know how to maintain it, improve it. So like for example, bird. These are bird, but when we predict, only the right hand side is with the beak, and the left hand side shows it. If we predict it as person, wrong prediction. person, it's because of these features. So from this XAI, Rise XAI, you know that whenever you have some bird with this kind of a big bird from the back view, you may wrongly predict it as human. Okay, so that is how XAI, Rise XAI works. You can also get the library from GitHub or Rise. You can go to this link if you are interested. So you can also refer to the paper from the author who created this Rise technique, if you want to use it. Okay. So quickly we go to the debate and the challenges of AI, how we see this for the future research. XAI is good. We say it's good because we can manage bias, we can increase our trust, consumer trust, creator or domain expert trust. We can promote transferability. So at the back, behind the scene, how it transfers. But with explainability, you know what is being transferred more, what is being transferred less. So it can promote transferability from one use case to another, from one application scope to another scope. Ensure reproducibility. You know how it works, so you can always reproduce with a better confidence of performance. Okay. Producibility is a very important characteristic when we do data science work or we create AI models. We want it to be always consistent. You don't want the intelligent application sometimes can work, sometimes cannot work, right? So next, it is without weaknesses. So what are the weaknesses, the major weakness that we researchers need to overcome or need to take precaution in the future? The very important one is the vulnerability on security breaching. When the deep learning model gives you prediction, it's black box, nobody understands it, so the hacker is having tough time to hack. But when you come out with the explainability, it increases the transparency of the model. So human easier to understand, hacker also similar, easier to understand, easier to reach. So that is one debate that researchers need to overcome in the future. AI application products, creating products, and is prone to unethical manipulation. When we don't understand, we do not know how to manipulate it. So, for example, you want to predict a financial terms, financial decision. When you do not know, you based on AI, you don't know how to. The workers or the user cannot manipulate. They don't know how to manipulate. But when it is when you understand it, it's more transparent. There comes the bad motive where some people may want to manipulate the Sorry for the interruption. So we may prone to unethical manipulation. So way forward, what can we look at for the into the future for those who are interested in this? Maybe I can find some colleague. I can find some friends here in this group which are also interested in using XAI, researching in XAI model and so on. So we towards domain-specific adoption. XAI comes in the picture with general definition, but when you come to different domain, it might have different requirements. For example, like I'm now doing the brainwave signal domain in authentication. So we have some requirement from the domain itself, where when we want to use XAI, we have to take consideration of that. So domain-specific adoption is what I see will be the one of the future direction in XAI. Second, how to quantify. When we say XAI, the benefit is for user to understand better trust, better acceptance. How do you measure this user satisfaction, trust and acceptance? is a more subjective measure. So how to create a quantifiable, more objective performance measure for XAI? It's also the way forward in this research area. We do have some objective measure, but it's not as good as what we have for machine learning model. So to measure the explainable model, the quantifier, the performance measure is different from measuring your machine learning model. Okay. Last, reliance issue. So we have to look at when the XAI explain the machine learning model, it explains how it works. But what if the machine learning model itself is not good? If the performance is not good, can we realize it from the XAI itself that this learning model is not good? Not the XAI model not good, the learning model itself is not good. That's why when I explain it, can I have some clue in your XAI model when you come across with those? So reliance issue is also another direction you can focus in, which I haven't come into this direction. I'm more focusing on the first direction and the second one. So this one is also an interesting one I see for the future. Okay. So at the end, why we are talking about explainability XAI is actually to create a safe AI engine. So this safe AI engine is related to responsible AI, and XAI, explainable AI, is one of it under the umbrella. So when you look at the example, you can find a clip Elon Musk talking about AI implication on consequences. Future AI engines, since they are becoming more and more, we want our future AI engine to be verified, able to verify, validated, secure, control. So we don't want them to go wild, self-replicate, self-repair, self-improvement, or is able to access to the energy resources. That will be dangerous. So to make sure all this happen, we have to consider the concern under responsible AI, including XAI. So I will use this as a conclusion. First, XAI has gradually become a norm. You can see from the trend, it's now normal in the emerging technology. It's already become a norm. Okay. Then we must be aware of the trade-off between explainability and performance. When now, at the current moment, we see that complex model give us better prediction, but lower explainability. So when we try to increase the explainability inside the model, somehow the performance might be sacrificed. So the research, in our research community, the work is to how to maintain the performance while be able to explain. That is the best case. If not, there is a trade-off that we have to balance out. Okay. Mission critical tasks significantly exclude XAI, the explainability or interpretability of the AI model, especially when you are creating the critical task application of AI. Interpretability is preferred, if possible, more than creating an explanation module. This is because interpretability is by design inside the learning model. The learning model itself is simpler, easier to understand. So that's why it's having higher interpretability. This situation is better. Then we need to create another additional one to explain the learning model outcome. So to put one more additional module inside the whole design is more difficult. So by design is simple, it's better. That's why this statement tells us that if our learning model if we are able to use a simple learning model, go ahead. Do not need to, not necessary to go into difficult, complex model. Okay, so the performance is similar, seem good. Then why we want a complex model? We should go for simpler model because of the explainability and transparency. So if it is impossible, there are a lot of cases impossible. That is the reason why deep learning is emerging so fast, because there are a lot of situations impossible. So when impossible, then we have to look at explanation module like the in XAI. So if it is impossible and we have to use this black box model, responsibility is very important. Do not forget about that. Okay. With that, I thank you very much for your attention, and I will pass this back to the moderator for question and answer session.